All right, guys, here we go. We're looking at one with a table here that deals with a lot of the different rules, kind of like the one you did Monday. All right, let's take a look at this in case they drop one of these in. I doubt we have an entire problem that's like this, but it could be a part E or a part F of one of the bigger problems. So let's take a look here. Let h be a continuous function given by that function there. Keep in mind, those are two different things. So when I take the derivative of that, I'm going to use the product rule. So leave 3x plus 1 alone. Take the derivative of f of x, which is f prime. Take the derivative of 3x plus 1, which is 3. Leave f of x alone. When you do that, what you'll end up getting when you plug in 4 is a 13 for that first expression, f prime of 4, which is 6 for the second expression, plus, well, 3 is just 3, and f of 4 also happens to be 3. So 13 times 6 is 78, 3 times 3 is 9, add them together, you get 87. For part B, this is going to be chain rule, f of x, okay? On some of these problems, you had f and g and h, and you've got different ones that are kind of working with each other. In this setup for this table, all I was given was just a function f of x. So the derivative of f of x is f prime of f of x times the derivative of the inside. So times the derivative of the inside. Plug in 1 for x. So I've got f prime of f of 1 times f prime of 1. Well, f of 1 is 4, so I've got f prime of 4 times f prime of 1 is 5. These are different things, guys. Don't look for f prime of 20, right? You got to kind of pay attention to PEMDAS here, going all the way back to grade school, thinking about, please excuse my dear Aunt Sally, the parentheses are important. We're doing f prime of 4, which is 6. 6 times 5 is 30. We come to the back here, guys, and now we've got some interesting stuff. Because what they're asked us to do is find the integral from 1 to 2 of f double prime of 3x. So we've got u substitution, we have got taking the integral of a derivative, and we've got a lot of stuff going on here. So if this was just f double prime of x, that'd be a pretty easy question, but it's f double prime of 3x. So I have to set u equal to 3x, du then would be 3 dx. Well, I have my dx, but I don't have my 3. So I got to put a 3 on the inside and 1/3 on the outside. That 1/3 follows through almost all the way to the very end. So now that I have that, I can write this in terms of u. And I actually have a little bit of a mistake here on my key. Because this in green, that's in terms of u, my limits should also be in terms of u. So when x equals 1, what would u equal? Well, 3 times 1, it would equal 3. When x equals 2, what would u equal? That would be 6. So as long as I've got things in terms of u, I have to have my number or my limits be in terms of u as well. So I've got 1/3 f prime of u from 3 to 6. I have to convert back to x because all my answers are in terms of, well, I guess I wouldn't have to because I'd have f prime of 6 minus f prime of 3. Either way, you get f prime of 6 minus f prime of 3. That would be 2 minus -1, which is positive 3, and 1/3 of 3 is 1. So all that work just to get us an answer of 1. All right, part D. Is there a value C over an interval? Guys, when they start talking about intervals and is there a value and justify this, 9 times out of 10, it's the intermediate value theorem, it's the mean value theorem, it's some theorem where conditions must be met to verify. So when you see, is there a value C over an interval, if that shows up on the exam, I want your brain to say, when I hear those words, I think mean value theorem. I think intermediate value theorem. So you already are narrowing down the possibilities. So let's think about what the mean value theorem says. Mean value theorem says that if a function is continuous and differentiable over an interval, then there's at least one value C, excuse me, such that f prime of x equals f of b minus f of a over b minus a. In other words, where the instantaneous rate of change equals the average rate of change. Since they gave me the interval from 1 to 3, I'm going to do f of 3 minus f of 1 over 3 minus 1. I'll work out that math and I get 3 halves. Since the average rate of change equals 3 halves, then the mean value theorem guarantees there's at least one value C where f prime of x equals 3/2. Another thing that came of doing this key, guys, is to really recognize that my handwriting is poor. Make sure that you, this is a big exam, it counts a lot for you. Make sure that you can read what you've written and that a reasonable person could read what you've written as well, not necessarily someone who knows your writing very well. So make sure that you write clearly on the exam. That will be important. All right, guys, there's a lot of information on the website today, shortcuts, keys, all kinds of stuff, kind of that when you see this phrase, you should think that. I've got a lot of documents there and also a breakdown of the types of questions that you might see and what to do in that situation. So please take a look at that and organize it according to your own kind of your own self, okay? Print them off at least and have them at the standby so that you don't have to flip through your binder. It is open notes test, so you can look at the stuff and say, oh, you know what? I've got to look at X, Y, or Z. Oh, man, I think this is the mean value theorem, and you go right to it. It's not something you got to shuffle through your whole binder for. So anyway, guys, I hope all this helps. We'll be in contact Monday. Have a great day.